And here we have it. Amazing! So much work, such a long breadcrumbs road, but we have our functioning modular prompt that we can reuse. Welcome back. Let's create a menu for our game. Navigate to the Widgets folder, right-click, go to User Interface, and select Widget Blueprint. In the All Classes section, search for Common Activatable Widget and select it. Name it AWB for Activatable Widget Blueprint with an underscore, base UI layout. Open the blueprint and add an overlay as usual. Since we're using a common UI in the base UI layout, we need to add stacks for our UI. Add 3 common activatable widget stacks. Name the first stack Player HUD stack. Name the second stack Menu stack. Name the third stack Prompt stack. Make all 3 stacks have horizontal and vertical alignments set to fill. Navigate to Widget Graph. Delete graph events. To add other widgets to the UI stacks, we need to create a custom event in the graph. Create a custom event called Push Menu. Drag the menu stack variable to the graph and search for the Push widget node. Drag the activatable widget class selection to the Push Menu event to make it an input. Repeat the same steps for the HUD stack. Create a custom event called Push HUD, drag the HUD stack variable, and add the Push widget node. Similarly, connect the class selection to the event. Create the last custom event for our prompt stack called Push Menu Prompt. This event will require additional work, so let's keep it as is. Don't forget to compile. In the Widgets folder, create a menu folder to hold the widgets we want to push to the menu stack. In Menus folder, create the main menu activatable widget named AWB_main menu. Drag an overlay and add a common button to it. Set the vertical alignment to bottom aligned, and then set horizontal alignment to right aligned. Name it Quit Game. Set button bottom padding and right padding to 20. Add a vertical box to the overlay and 2 buttons to the vertical box. Set the horizontal alignment to right and the vertical alignment to center. Adjust the padding of the vertical box. Set top padding 200, right 20. Name the first button Create Lobby and the second one Search Lobby. Compile and save, then Done with changes. Let's name the buttons in the hierarchy with appropriate names. For the Quit Game button, name it Quit Game and so on. Now we have our menu. We can add more to it as the need arises. For now, let's add it to the screen in the menu map. Go to the blueprint and open our menu controller. For the Begin Play event, add a Create Widget node. Search for our base UI layout widget. Set the owning player as self. Promote the return value, which is our UI layout widget, and name it Base UI Widget. Drag the Base UI widget and search for the Add to Viewport node. To avoid having to log in to see the menu, let's open the menu map. If we play now, nothing happens. We just added the base UI widget that is responsible for stacking widgets. Go to Menu Controller. To add a widget to a stack, we need to get a reference to our base UI widget. Search for the push menu event we created in the base UI widget. Choose our menu widget as the activated class. Compile, save, and play. Here it is. Our menu has been pushed to the menu stack. Great start. Now it's time to create the quit game function. For that, we need the quit button to create a prompt with a yes and no selection. Let's make the prompt widget modular. Let's create it in the Modular folder in our Widgets folder. It needs to be of the activatable widget class. Name it AWB_menu prompt. As usual, add an overlay. For fun, let's create a new border style. Go to the UI and Styles folder and add a new border style named borderstyle_LED. Open it and search for an LED image to add as the background. Now add a common border to the overlay and set it as our LED border. Make it center aligned. Search and add a vertical box to our border. Inside the vertical box, add a common text. Also, add a horizontal box to our vertical box and add 2 common buttons to horizontal box. Select our text and make it center aligned. Our prompt is starting to take shape. Let's name our buttons yes and no in the hierarchy and for the button text. For the text, set it as a variable and name it prompt text. Now I notice that in my other project, I used the bold Montserrat font. So let's change it in our text style. Yep, it looks better. At least for me. The menu as well. Maybe too bold, but it's fine. It's example project. Now let's go to the prompt widget graph, delete the pre-construct and tick events. Create a custom event and name it set menu prompt info. Drag the prompt text variable and search for set text. Drag the in text to the event and name it prompt text. Now, step by step, let's integrate the prompt functionality. First, in the main menu widget, we add a quit button, click event. Delete the rest events. Now this widget has no idea what's going on in this world. That means we need an interface so it can communicate. Go to our interface folder and create one. Name it BPI_PC_widget manager. PC stands for player controller. Now, for the new function, let's create one to push a menu widget. Name it PCWM_push menu. I found that the practice of naming interfaces with special acronyms helps me navigate and search for logic I'm making with them. Since we already have a push menu event in our base UI widget, this naming convention will be helpful. In the same manner, let's create one for push HUD and push menu prompt. Now we need to add an input to the push menu function. Search for activatable widget and choose class reference, not object reference. Name the input activatable widget. Do the same for push HUD. Now you don't need to set the activatable widget class as it uses the last created value. So neat. For the push prompt function, we won't be passing the activatable widget. Instead, we will pass the text for the prompt. So change the input to text and name it prompt text. Don't close the Widget Manager interface as we will be needing it soon enough. Don't forget to compile and save. Navigate to the menu controller and add our newly created interface in the class settings. Double-click on Push Menu, then HUD, and lastly Prompt. For the Push Menu event, drag our base UI widget and search for Push Menu. Connect the activatable widget as the input. Make sure you're not calling the interface's push menu, but the native widget event. Do the same for the HUD and prompt events. Now, our push prompt function doesn't have any text input since we didn't make it an input parameter. You can double-click on it to bring us to that event in the widget. Add an input to the event and set it as text, naming it prompt text. Now we can connect the prompt text from the interface to our widget event. Go to the main menu widget and for the Quit Game button, click Event, get the owning player and add our PCWM push prompt interface call. Inside the prompt text, write, "Are you sure you want to quit the game?" Let's test it by playing our menu map. And nothing happened because we skipped a step. Our base UI layout widget does nothing until it receives the push menu prompt to trigger event. Drag the prompt stack variable and search for push widget and select menu prompt as the activatable widget. Drag from the push widget return value and search for set menu prompt. Connect both prompt text inputs to each other. Compile, save, and let's test it. It works. However, the buttons don't work because we haven't implemented functionality for them. It won't be hard, but it might at first fly overhead. But first, I want to create some new styles for our buttons. Let's duplicate our common button style and add hovered red to its name. Open it and go to the normal hovered and navigate to used material. Duplicate our button material and add red to its name. Open it and change its color to red. I will use the same color for all selections, but you can make it less plain if you prefer. Now, replace the old hovered material with the red one. Do the same for the pressed material. Go to the main menu and change the Quit Game button style to hovered red. Let's also change its hovered sound to backclick 09. Play the level. Nice. Now the Quit button turns red and produces a different sound, catching the eye that it's a different button. Now let's do the same for our prompt. But first, let's make a green style button. We can duplicate the red style and change red to green. Just follow the same process we used for the red button. Make sure you're changing the green button style asset. Change the hovered click sound to backclick 04. In the prompt widget, change the No button to hovered green and the Yes button to hovered red. Great. Everything seems fine. However, when clicking outside the button, the mouse disappears into the game void. To fix it, let's go to the main menu widget graph. Since we're using a common UI for our UI elements, the activatable widget has an onActivated event that triggers when it is pushed to the stack. Search for the onActivated event. Get the player controller and search for Set Input Mode UI only. Also, drag off the player controller and add the Set Show Mouse Cursor variable. Set it to True. That will fix the disappearing mouse. Now we can click around, and the mouse will stay on the screen. Now let's continue making out prompt widget function. For that, we need two enums. Go to the UI folder and create a folder named UI Enums. Inside this folder, let's create our first enum named e_prompt_index. Create one more named e_prompt_to_stack. I promise it will make sense. Open the enum for prompt index and add an enumerator named exitGame. And for the enum prompt to stack, add enumerator names menu stack and one more named HUD stack. In the Player Controller Widget Manager interface, add an input for push menu prompt. Make it of our created prompt index enum. Name it prompt index. Add one more input for prompt to stack enumerator and name it prompt to stack. Compile save, and now we can close this interface. Go to Main Menu Widget Graph. And I noticed I made a mistake by selecting the wrong enum. So now we can set two enumerators for our prompt call, one for what it does, and one for the stack it originated from, and eventually send a response back. Now let's spread the breadcrumbs. After the button click, we end up in the controller. Now the controller needs to pass all the data to our base widget. So we need to add the same inputs for push menu prompt. Add both enumerators as inputs. Now, in the return, the base widget needs to pass all the data to the created prompt. Add the same enumerator inputs to set menu prompt info. Drag each incoming enumerator and promote them to variables so the prompt widget can store them for later use. OCD killing me to make everything in order. So, all the way from when we click the menu button to show the prompt, all the data goes to the prompt widget. Now we need to use it to make things happen. Let's start with the Yes button. Add an on-clicked event to the graph. Do the same for the No button as well. Save everything if you haven't done so like me. Now, once again, we take one more leap of faith. Go to Blueprints and create an actor. Name it BP_MasterBinder UI. Here, For the event dispatcher, we add a dispatcher named onPromptConfirmed. All dispatcher names start with on. Add another dispatcher and name it onPromptCanceled. I hope you see where we're going with this. For onPromptConfirmed, add an input and make it of type PromptIndex enumerator. Name it PromptIndex. Let's use the remembering feature and add the same enum to the onCancel dispatcher and name it PromptIndex again. And another one for the prompt to stack enum. Name it prompt to stack. Do the same for the cancel dispatcher. So, in short, for the dispatcher, we need a hard reference to bind and call the dispatcher. We will use this actor, which is 34 KB in size, as a reference for any dispatcher calls. It's our transmitting tower. Now, who will send the message? It will be our prompt widget. First, we need to get our master binder actor reference. To do that, on the event construct, search for get actor of class. For the actor we're looking for, set it as our master binder. Let's promote it to a variable and name it master binder UI. And now, on the button clicked Yes event, we get our master binder and call our onPromptConfirmed dispatcher. Connect our save variables to the inputs. Connect index to prompt index and stack to prompt to stack. And here we have a dispatcher call, the transmission beginning. Let's make a dispatcher call for the no button as well. Call the onPromptCancel dispatcher and connect our enums. Now we need a receiver. But first, I forgot, for the widget and receiver to get this actor, we need to place it in our world. In our case, it's the menu map. Drag the master binder to our level. Now, our menu controller will serve as the receiver for our dispatcher call. At the end of the begin play, drag off the last node's in pin and search for get actor of class. For the class, set it as our master binder. Promote it to a variable and name it master binder UI. Let's create a custom event and name it bindings. Get our master binder. Set bindings event after setting the master binder variable. In simple terms, this is where the master binder will get messages from the prompt widget and will tell our controller what to do. Drag off the master binder and search for assign onPromptConfirmed. If you add a dispatcher with the assign tag, it will create an event for us. Connect it with bindings. Now we have a receiver with incoming inputs from our prompt widget. For now, let's continue with the confirmed dispatcher. Drag off prompt to stack and search for switch. This function allows us to switch depending on the enumerator we received. Drag the base UI widget and from it search for menu stack. From the menu stack, search for get active widget. The output is a generic activatable widget, so to communicate, we need an interface. Let's create our last interface for now, named BPI_prompt_interface. Open it, and let's create a function named prompt_confirmed and prompt_cancelled. For the input, add the prompt index enum and name it prompt index. Do the same for the cancelled function. We don't need to pass the prompt to the prompt as it served its purpose. Compile, save, and close. Go to the main menu and add the prompt interface in class settings. Double-click both to add them to the graph. Go to the controller and now call our interface for prompt confirmed. Connect the incoming prompt index with our interface. Compile and save. And in our main menu for confirmed, we drag out our enum and search for switch. We have just one option for now, but later we might have more. Drag off exit game and search for quit game. If we did everything correctly, clicking the yes button in the prompt should close our game. Let's test it. It works. Job well done. Let's collect all the breadcrumbs. We click our main menu button for quit game. That button, in return, creates our prompt widget. We get all the data sent to us to create prompt. On yes, we send a dispatcher call with the help of our master binder for what to do when yes is clicked. Our controller, in the meantime, at the beginning of the game, got our master binder, saved it as a reference, and bound the dispatcher event for use when the dispatcher call happens. And then it happens, we trigger this event, and it checks what enum we got and tells our main widget to whom this call was. In our case, it's the menu stack. And then the menu stack got an interface call to trigger prompt, confirmed with the enum to know what to do. In this case, close the game. Now let's do the same for cancelled. Drag off the master binder and assign on prompt cancelled. Drag of master binder and type assign on prompt cancelled. Drag off the prompt to stack and search for switch. We can copy and paste the get active widget and drag off the return value and add a dispatcher call for prompt cancelled. Connect it to the menu stack and connect both prompt indexes. Now in the main menu, drag off the prompt index and add a switch. First, let me show you. If we click Quit Game, the rest of the buttons can still be clicked, and we can even click Quit Game again and again. Let's fix it. Go to the designer and name the vertical box as Lobby Box and make it a variable. Now in the graph, drag the Lobby Box and look for Set is enabled. Keep it as false. Also, drag our Quit Game button and connect it as the target for Set is enabled as well. This neat function takes multiple variables as a target. Compile, save, play. Now we can't click the button when the prompt is added to view. We will fix buttons turning white later. Now, on prompt cancelled, let's do the reverse and enable them back. Copy those nodes and set them for exit game and set true for is enabled. And on no in the menu prompt, on no, deactivate the widget. Play to test it. Great progress. Both buttons are now working as intended. Now let's go fix the buttons for the disabled state. Navigate to UI, Styles, and open each button style. Now we set the disabled material for each of them. Navigate to where our button materials are and duplicate our button material, remove hovered, and name it disabled. Open it, and for all colors, let's make it gray. You can hover the mouse over button color 1, hold Shift, and press right-click. Now hold Shift and press left-click to set the color for the rest. Now, for each button's disabled image, set our created disabled material. Let's play our menu. And here we have it. Amazing! So much work, such a long breadcrumbs road, but we have our functioning modular prompt that we can reuse. Let's do one last thing. Go to the menu controller, select the binding event with all the nodes, right-click on our event, and select Collapse Nodes. This will put all the nodes inside this graph. Name it Master UI Bindings. Now our graph is cleaner. You can put it anywhere you like or close to the binding event. Well, finally, we have our menu. We have a modular prompt that took ages to make. And finally, we can move on to creating our lobby. Again, there will be plenty of UI to make, but in return, we will have a customizable lobby. See you in the next one.